Hello everyone, welcome to this video. In this video, we will discuss on LeetCode problem number 966, which is Vowel Spellchecker. So let's go through the description. So here we have given a word list and we want to implement a spell checker that converts a query word into a correct word. Okay, we have given this word list and the queries, and we want to convert a query word into a correct word. So for a given query, the spell checker handles two categories. One is capitalization and another one is vowel errors. So in capitalization, if the query matches a word in the word list, irrespective of case sensitiveness, so what does it mean? That here the query has this capital Y character and the word list has a small y character. But still, we consider these as a match because this is a case insensitive. So we will return the same case as the case in the word list. So we will just return this word, right, from the word list. So you can see here, right, that the query has capital Y, here the word list has a small y, right? But still we consider this as a match. And then this E is also matched with E, L is matched with L, capital O here. Here we have a small o, but we will consider this as a match because this is case insensitive. And hence since this is matched with this word list, so we will return the word list value, which is yellow. Similar to this, here this is matched with this if we don't consider the case sensitiveness, and hence we return this word list, which is capital Y E L L O W. And similarly in the third example, it's actually a perfect match, so we just return the yellow here. Now let's talk about the vowel errors. So if after replacing the words, vowel words, which is A, E, I, O, U, with any vowel individually, it matches a word in the word list, then the query word is returned with the same case as the match in the word list. Okay, so let's understand this. Here also it is case insensitive, right? So small y and the capital Y is considered a match, right? Now here we have O, here we have E. But since we are saying that any vowel individually can be replaced with another vowel. So here we can replace the O with E, right? And then it will be considered as a match, right? And since we are saying that okay, O is replaced with E, it doesn't mean that all the O's here will replace with E, right? It is individually. So we are just replacing this position, second position wala O, okay? Then L and L is matched with L and L. Then a small o and capital O. But since it is insensitive, so we can consider this as a match, and then W. So all the characters are matched as per this condition, and hence we return the word list. So which is this value. Similarly, here if we see capital Y, small y is a match. E and E is a match. Now here we have E, but here we have L. Now remember, a vowel can be replaced by another vowel. So here we cannot replace E with L because L is a consonant, right? So we consider this as a mismatch, and hence we return as no match or the empty string. Similarly here we anyway don't have the same size count, so we will return as no match. Okay, now in addition, the spell checker operates under the following procedure rules, precedence rules. So there are basically some precedent rules. First is it will try to find the exact match. When we are saying exact match, yani, it will be a case sensitive, right? If we find the exactly match, like in this scenario, then we will return this value first. If we don't find the exact match, then we try to find the matches a word up to capitalization, right? And if we do, and the first occurrence, the first word which matches up to return the first such match in the word list, right? So first word in the word list which will matches a word up to capitalization, that value we will return. If that condition is also not satisfied, then we will return the vowel errors. Okay, and if none of these are matched, then we will just return the empty string. Okay, we can go through this example to understand it more. So here we have a word list. These are the many words we have, and then the corresponding queries we have, right? So let's go to the first query, which is a kite. Now, if we try to find the kite here, we first try to find the exact match. We get the exact match here, which is at this second position. So we just return this word as it is. Now we go to this one query. It is so we don't find the exact match in the word list. Then we will go on capitalization. So we will first check with the first word. So here we can see that after considering this T and this T as same, like if we remove the case insensitiveness, then this will be a match, right? This is a capitalization match. Hence we will return this word. So this is our output. Similarly for this, it has a perfect match with the first one. So we just return this first word value. Then this one, it has a perfect match with the this fourth wala word. So we just return this fourth word here. Then for this, it has a there is no perfect match. So we will go with the capitalization, and we found that this particular is a match with this one. If we don't consider the case sensitiveness, and hence we return this here. For these two, there is no perfect match, there is no capitalization match. Now we will try to find the vowel match. So if we compare this and this, right? So H is matched with H. Now E is vowel and A is also vowel. So E can be converted to another vowel which is A. So this can be matched as well. But here the third character, right? Here we have A, but here we have R. Now you cannot convert A to R because R is a consonant. Hence, it's a mismatch and we return the empty string. Similarly, this will also, we don't have any match for this, so we will just return the empty string and so forth. So on, right, for the other queries. So this is how we will need to solve this problem. If we look at the constraints, the length of the queries and the word list are less than 5,000 and the length of the each word or each query will be of maximum 7 characters. Okay. Now let's try to solve this problem, like how we are going to. So it's actually a very straightforward. What we need to do, we just need to do what we need to ask, right? Basically, we will first try to find we will loop through each query. We will try to find the word from the word list, exact word. If we don't find, then we will try to find the capitalized word. And that also, if we not able to find, then we will go to the vowel error. So first case is simple. To find the exact match. Exact match is just we just need to find whether this word is exist or not. Whether query word exist or not in word list. This is like a pretty simple, right? Now for capitalization. So what we can do here, so we get the query word. We will, since capitalization means a case insensitive, right? So what we will do, we will just we will first do the lower of this query. That means if the query has any capital character, we will convert that character in the lower case, right? So we will first do the lower of query so that it will have the small case characters only, right? Similarly, we will try to find, let's suppose this is equals to lower word or lower query, I would say. Okay, and then we will also convert each word on the word list into a lower query, lower word. And then what we need to do in the end, we just need to find whether this lower query is matched with lower word or not. Simple. Now if we get a match, we just return. Now let's suppose we don't get a match from exact match, we don't get a match from capitalization as well. So we will go on vowel errors. For vowel errors, what we will do, we will convert the vowels. First, we will do the lower of the query because the vowel error is also case insensitive. So we will first go with the lower query. Okay, we will just convert all the uppercase characters into lowercase, and then we will perform the vowel operation here. So we will convert the vowels into some another character. Let's suppose like this. We will convert the vowel each every vowel into this star character, right? So we will get the vowel query. Similar operation we will perform on each word in the word list. And then we will compare, we will say this as a vowel word. Then we will compare this vowel query with vowel word. Okay, I hope you get it. So first for the exact match, we just need to go through all the words in the word list and we will see whether this query word exists or not with the exact match, right? If it is, then we just simply return that. If not, then we will go to the capitalization. So what does capitalization means here? That we consider a match if the character is same, even if it is case insensitive, right? So for that, we can first convert both the left side and the right side, which means both the query and the words in the lower case characters. So if we have any uppercase characters, we are converting it into a lowercase characters for both in the query and in the word list, right? So let's suppose we get after converting this query string into a lowercase, we get this lower query, and also for each word in the word list, we will convert so we get the lower word, and then we will compare the lower query with the lower word. Now let's suppose we don't find the match here as well. Then I will go to the third step, which is vowel errors. So vowel errors are also case insensitive, right? So we first convert that into the lower query and then we will convert all the vowels that we have into star, right? Because each vowel can be replaced by another vowel, right? So we can say that all the vowels are same here, all the vowels can be considered as a match, and hence we are converting all the vowels into a one character, which is a star. Similar operation we will perform on each word in the word list, and then we will compare these two words. If we don't find any match here as well, then we will just simply return the empty string. Okay. Hope you get this. Now let's go through the code. We will get a more idea on this. So first we will create a unordered map which will store the vowel words and then the capitalization words and all, right? So first it will store the perfect mesh, second lower, and third is vowel. Okay, now what we will do, let's go through all the word list, all the words from this word list. So for the perfect, we just need to store it as it is. Okay, for a lower word, we first need to convert this word into a lower word. So let's suppose we define one function to lower, which will convert this word into a lowercase character. Okay, so any uppercase characters will get converted into lowercase and we get this one. Now remember that we need to return the first return the first such match, right? So if this lower word does not exist in this particular map, then only we will update it with some value, right? So if lower dot find lower word is equals to lower dot end, that means this word does not exist as of now, so we will just initialize this lower word with this word. Similarly, we will have one vowel word. We will have one function which will do which will do this operation. First, it will convert the into all the uppercase character into lowercase character, and then convert the vowel into star. And then similarly, like this, we will do if it does not exist right now in our hash map. Then we will store it. Okay, now we have performed all the operations like a perfect match, lower conversion, and the vowel conversion for this word list. Now we will try to go through the each queries and compare, and we try to find the match. So first we will have one string result, a vector of a string. We will define the vector of a string result. Okay, then we will go through each query. Okay, now first is the perfect match, right? So if we found this word query here, then we just push the perfect word, right? If not, then we will go to the capitalization. So if we found the perfect match, then we just simply push the perfect word in this result vector and then we just do the continue. If not, then we will go to capitalization. So for capitalization, we will just convert this query into the lower query word. Okay, and then we try to find this lower query in our this hash map, lower hash map, right? So if lower dot find lower query is not equals to lower dot end, then similarly to this, we will push back the lower query word and then continue. If not, then we will go to the vowel errors. Okay, so again we will create one vowel query, and then similarly we will have this match condition, that if vowel dot find vowel query is not equals to vowel dot and, then we will just simply push the this vowel query word and continue. Now if we don't find any match, then we will just simply push back empty string here. Okay, and then in the end we will just return the result vector. Now let's define this, create this two lower and two vowel function as well. So we first create a two lower. So in the input we will have one string s, and then let's suppose we will return another string which will have all the characters in lower case. So for that we will go to each character of this string s. We will check whether these characters are uppercase. So if character is greater than equals to A and character is less than equals to Z, that means all the character is in uppercase. So we need to convert it into lowercase. So how can we convert that? So we will just need to first do, so we need to push back the lowercase character, right? And to get the lowercase character, what we will do? We will first do the minus from A and then plus of lowercase a. So it will give us a lowercase character. Else, if it is not an uppercase, then we will just simply push back that character. Okay. And then in the end, we will return result here. Now similarly, let's first go to two vowel function. So for two vowel, we first need to get the this lowercase word, right? So first let's define the string result as empty string. Then we will store the s as two lower of s. Okay. Then we will go to each character of s and we will say if this is vowel, if the character is vowel. So if is vowel, then we will push back that is star character. Else we will just push back this character only. Okay, and then we will return result. Now let's create this is vowel function as well. Sorry. So we have this character ch which contains only lowercase characters only. So we just need to return that if the character is equals to a, or character is equals to e, or I, o, or u. Then we will return true, else we will return false. Let's go through this again. What we have done, we have created two functions, two lower and two over. So two lower is just simple. We will go through the each character of this string. If the character is in uppercase, that is if it is greater than or equals to a and less than equals to z, then we will push back the corresponding lowercase character. So that corresponding lowercase character is ch. First we will get the index, right? Like if it is a, then it is the zero index. If it is b, then it is the first ASCII value, right? So ch minus a, and then we will just do the plus of a, so that it will give us the corresponding lowercase character. For two vowel, first we will get the lowercase characters of the string, right? We will convert all the uppercase into lowercase. Then we will go through this string s and we will check If it is a vowel, then we will just simply push back a star. If not, then we will just simply push back this character only, right? And we have created this is a vowel function which will just return this as true if the character is equals to e e i o u, else false. Okay, now let's try to run this test cases. Okay, I think there is some spelling mistake here. Oh, okay. It is a small word list only. Okay, our test cases are passed. Now try to submit this. Okay, so our code is submitted. Now let's try to understand the time complexity here. So here we are going through the each word, and then we are just simply inserting this into this map function. So it's just O of n. If it n as a word list and m as the query size, right? Then for each we are going to each query and then we are trying to find the words there, right? So this find function will take O of log n, right? So here our time complexity will be O of n into in the worst case, right, because we have defined this as unordered, so in the worst case, it will take the n length, right? So query is of n size, this word list of n size. In the worst case, this our find function can take O of n. So our overall time complexity will be O of m into n. You might think that what about these functions? So we know, right, that the length of the each word is less than or equals to 7, right? This is what we have given in the constraint. So this looping through each string right here, it can be of maximum 7 iterations, right? So this is the constant time here only, right? So this function will not take any time, any time complexity here because it's a constant time only. Similarly, our space complexity will be maximum. We are first we have declared this three unordered map, right, which will store the word list, and then we have this string result factor as well. So space complexity we can say as the extra space complexity we will say because this is string result anyway we will need it. So space complexity or the extra space complexity will be O of n, which is storing this all word list words, right? Okay, I hope you get this problem. You understand this problem and how I solve this. Hope you. If not, I will. I will recommend you to solve this problem by yourself once after watching this video. So you will get a better idea on how to solve this. Okay. Thanks for watching the video. Bye.